Maybe first I will maybe read one question you already started to answer in the live notes, but I think it was an important one. It was, what's your view about the, I think it's related to this usable capacity concept, which means that the value of a resource may be very different from one workload to another one. And probably on the experiment side, this is a good thing that we have this fine-grained view of the things. But when it comes to pledges and thus to funding agency, the fact that the resource has not the same value depending on the workload can be a problem. How do you see this?
I think it's just a fact. If your experiment doesn't have a reconstruction code that can use a specific accelerator on the side, you are missing out of something like 80 to 90% of the potential of that resource. So this means the value for your experiment is very low of this resource, while another experiment that has code to use this can benefit a lot. So the value is very different. So it is. I think it's in the nature of these resources. These are no longer general purpose resources. These are like also the same as if you have a lot of machine learning to do, and the system offers a TPU. This is good for you. If you have less machine learning to do, it's not so good for you. So this means you cannot assign any more one value because these are not general purpose tools anymore.
Okay, so if I understand, at some point you said this is the way the experiments manage their pledges, and currently they just ensure that they have enough of the global uniform resources. They will have to ensure that they have enough for reconstruction, enough for simulation, and so on.
So as a community, one of the approaches would be to invest together into getting the software that everyone uses to support these accelerator-based resources first and well, which would mean the detector simulation and also the next leading order event generators. So this would be so if this is managed, then basically all experiments can profit from these resources in a comparable way. And also for reconstruction, there have been joint activities to have, for example, building blocks to build a tracking code between the experiments. And in my view, these activities become more important with a look to heterogeneous resources, because expecting that every experiment's ports on the order of 4 or 5 core workloads to all the architectures that are there, it's very frightening from the amount of resources that would be needed.
Okay, thank you. So Liz, you raise your hand.
I had maybe a more mundane question about the benchmarking. So you said that you would provide a number and a weighted number, and the weighted number would be based on what exactly? The amount of wall clock time spent in any particular part of the benchmark? I didn't quite catch that, and I'm a little worried about it. So could you explain?
Yeah. So the idea is that our measure will be based on the event throughput. Mm-hmm. Each workload reports this, and we collect the information for all the workloads. Now, the point is that if we need a single value, so like it's HPCs, we can use HPScore. And to do that, we can average the different event throughputs from the different workloads. So to get the average event throughput, we will use the one from CMS Gen, CMS Sim, Atlas Gen Sim, okay? Now the point is that we can decide how to use it. Today, for HPCs, we wait the 7 benchmarks that are in the HPCs 06 without any weight. So each of them weighs equally. So this means that if one in the new architecture diverges, so it will weight 1/7 of the other. We can do different things with our F score, because we can weight the different workloads differently. But this is a feature that mainly I would consider that we give to the community. So it's up to WLCG to decide if generation should weight more than simulation or less than reconstruction, okay? And if one from an experiment should weight more than the one of another. So we give the freedom in the approach. Then this should be fixed by a policy.
Okay, I'm just a little worried about incentives in that scenario where, you know, the people whose code runs for the longest is maybe the most inefficient code, and therefore their benchmark gets weighted better because they run inefficient code. So it's just a matter
Now,
of
if we state the efficiency in any case, so Marcus was mentioning that already today we don't have software that runs at the best and uses the best the CPU, but we know that the experiment have to process a number of events per year or simulate a number of events per year. So privileging who has the highest event throughput and not the longest CPU efficiency of work clock, but the highest event throughput means that it will finish accomplishing the processing of 1,000 of events faster. Okay, so this is probably a fair approach respect to CPU runtime.
right. Okay.
Yeah, and also one has to see that for the site that is using this benchmark during the purchasing process, for sites that supports multiple experiments, even if one experiment is very inefficient, nevertheless they have to buy the system where the overall number of events that they can produce with a board resource is maximized. So that aspect is also an aspect of a benchmark, the purchasing process.
Right. Yeah, I agree. The site has to provide for all of its customers, you know, equally or according to its policies. But I would not want to, so it has to be considered, but I would not want to provide the wrong incentive and say that that experiment just gets a pass because, I don't know, for whatever reason, it can't improve its code.
Yeah, I see this incentive problem, especially with pledged HPC resources. If you do basically nothing, the value of these resources that they have as pledges for you will seem to be very low. So there is a kind of incentive problem. This is why I kind of suggested that these how much the workloads realize what the system can do is made visible, so that an incentive is given to improve this. So which also could mean that if a funding agency insists on pledging a complex new architecture, that they also find the money to support the adaptation of the software.
Yeah,
okay,
in
so
general.
I think we probably need to move to, there are several other questions. I think it's an important point, but probably we'll have to rediscuss it in the future because it's probably not the end of the story for this. No. So I will give the mic to Helge. Helge, you raise your hand.
Yeah, but what I intended to say was mostly said already. I think the challenge is really that we want one number describing the value of a resource. Call it processing, let's not call it CPU anymore, but we want one number that describes the processing value, which is what we need for the whole pledge process. And this, I do not quite see yet how we can get there, but this is clearly the direction to take.
Domenico, Marcus, do you want to comment or?
Yeah, I agree with Helga, and this is why I also suggest for the pledging that we have to include more of the system. So while these self-contained running is very important for the purchase process, where you give things also out, for the pledges it has to be closer to what later is run on the system. So this means including having the data on the local storage system or accessing it through the way it will be accessed, having a CVM FS system there where you get your software from, so that all these things that have an impact are actually really taken into account. Because we are not interested in blindingly fast CPUs, but we are interested in throughput. After all, what we do is still high throughput computing.
Well, to add a comment, so it's exactly what indeed happens today. So we value the resources in HPCs and also experiments claims how many CPU hours normalized to HPCs they will need. This is in the pledging phase. And then in the review phase, what happens is that you convert the number of events that have been produced or processed renormalized to HPC6, but indeed in that renormalization, something else enters also, that is the efficiency of the site. This is already taken into account. It's not just the conversion of what is the workload efficiency at the time when you run on a single node, because you have to keep into account all the efficiency of the network, the storage, or the rest. I will not consider this as a new activity that we have to do. We have only to apply the approaches that we have already in hand.
Yeah, indeed.
Paolo, you wanted to say something?
Yes, it's related also to my last comment in the doc. I think that one issue which I have with the approach that Marcos outlined, and also the answer to Liz seems to hint, is that WLCGs correctly is worried about the usability of these machines, but it's trying to take a decision for the experiments, which I don't think they should. So the usability is a problem of the users, which in this case are the experiments. So if CMS decides to run all of their simulation on GPUs and Atlas decides all their analysis on FPGAs, there is no way that a single weighting can capture this. So I think what we need to move towards is a system in which pledges are obviously managed by WLCG, but the definition of the unit of pledge is experiment dependent, because you cannot you can't possibly have the same pledge for okay.
But this was never differently intended. So also if you look at Domenico's talk, you get a record on how the different workloads have performed. And by that, it's very clear if a site supports Atlas, then the Atlas workloads matter, not the ones from LS or LHCb.
But also, also the sites on which one runs, they may be influenced, this pledge, they may be influenced by the choices of the experiments. But okay, I'm happy we're on the same page there, and then I think I think that can work.
Maybe there is one last question for one last request to speak by Martin.
Okay, I was going to touch upon that very same point, right? That essentially we should now also profit from the fact that we can have, let's say, measurements that are really consistent with what user communities are going to use a particular resource, particular site, right? So not basically pull in workloads, let's say, that are not realistic. And so that's a new dimension, I would say, to our benchmarking and pledge process. The other thing is a comment on what was said a few minutes ago. I think you have to be very careful, let's say, with not mixing things. The benchmarks are really for measuring what, let's say, the computing, well, the CPUs/GPUs and so on can do, right? So those things, you should not basically worry about network problems and stuff like that. That is orthogonal to this, right? It's to measure basically how much power you can get out of those hardware resources, and of course, let's say the workloads should be somewhat intelligent, right? So they should be somewhat realistic. Well, they should be realistic, right? That's the whole point. But we may not be able actually to make them perfect quite yet. But they, and then you measure basically, right? Assuming, shall we say, maybe infinite network performance and all that.
Maybe to
No.
want to say something?
Yeah, that I don't really agree with that. That this is a dominant thing. It's important to understand what the computing part of the system can do, but at the end, what defines the value of a system for our community is what amount of work you can do. And if you have a poorly balanced system, then where you can't access your data, then it's doesn't matter how fast the CPU is.
Yeah, but Dominique already said this, right? We had this problem forever, right?
Yes, but we had it in a
perfect chips, right? But if their network or storage element is screwed up, of course, it's not going to be efficient.
Yeah.
Maybe a question that is in the live notes, somewhat related to this, is also the fact that in particular when we speak about GPU-based resources, there is more layers involved in the efficiency than for CPU, in particular all the drivers, libraries, and so on, that are improving rather quickly. So how do you envision the fact that we reassess regularly the value of a system that may change year after year or every 6 months?
So in the written questions, I think we already answered this. So these things don't move that fast. So kind of writing code, production code that supports a specific type of accelerator is not emerging every week or month. So we're talking maybe looking at a re-evaluation of the value once a year, once every 2 years.
It's necessarily our code, but the fact that you are the new version of CUDA or of the compiler or whatever may radically change the performance of your application without you rewriting anything.
Yeah, but it's the same problem. We have compilers.
A lot of these drivers change every few months, and they can be huge differences in their performance.
So if I can comment there, so I think that we have in hand a tool that allows us, in case this happens, to evolve quickly, as quick as it will happen for the software that then will run there. Because if CMS Patatrack will run with a new driver faster, then we can profile the resources with a benchmark based, guess what, in any case on CMS Patatrack that runs with the same set of libraries. So this is not possible today with an industrial standard because we have to fix it and then keep it as it is for 10 years potentially.
Yeah, exactly. So, but also I think the limiting factor is no longer the way to generate new versions of the benchmark. The limiting factor is to verify that what these new versions do actually is the same what we expect. Even with GCC versions, we did with students from Lund a study. You have not the same physics results by going from one version to another. And this means whenever you do a major change in the libraries that you use, you have to do a physics validation. And that doesn't come in a month.
This is what we will discuss right after.
Yeah.
Maybe
one of the problems with what you just said, Marcus, is that we are not anymore, we cannot choose anymore the version of the drivers. That is site dependent, and we don't have control on that.
So maybe I think we need to finish this discussion and move to the next session. So there are still two raised hands. So Doug, do you have something you want to comment?
Yeah, I'll be quick. The drivers that are available, the HPCs I use, don't change all that frequently. It's a few times, you know, it's quarterly or maybe a little bit frequently, but they do keep the old ones in place typically. Two, I want to sort of second what Marcus said about site usability. I'll give a very concrete example that happens today. Atlas is able to use the K&L at Argonne, but CMS is not because of the way our workload management system works. And even if the benchmarks can run on those machines and give good results for Atlas or CMS, if it doesn't work in the global system, it doesn't matter. And then it requires human resources to make these systems work. So I do think you have to fold that in, unfortunately.
Yeah, I
yes,
agree.
but sorry. So you just rephrased what we were mentioning. So you can give with the benchmark the potential that also for CMS will be high, but then you demonstrated that there is a lack of work or a need of work on the workload management system that will enable this. And this you can evaluate as a cost or a benefit, and then say we will have to invest on manpower to do the appropriate development. So this is an efficiency, an efficient factor, not the performance of the CPU GPU.
It's an economic argument. To gain access to so and so many additional events per second, is this worth to put a quarter of a person for 6 months on enabling this? So and for this you need the benchmark to know what you could potentially get from this resource, because otherwise you don't know whether the investment is worth the effort.
So maybe last question,
Yep.
maybe, so Helge.
Well, no, just to comment
last remark.
on the discussion we have had in the last few minutes. I believe there's an important difference between what was happening in earlier times with sites that were pledging to WLCG and what is happening now, what we are discussing now in terms of the HPC centers. In that, even if a site may have served many more communities than the LHC experiments, the LHC experiments were a major part of the consumers of the services. So if ever a site had poor network connectivity or chose all the wrong storage, they could score very well concerning the CPU benchmark, but they would be little used and there would be questions which would have been painful for the sites. So there was a mechanism by which the sites had an incentive to work on this and fix the problem. At HPC sites, there is the possibility that an LHC experiment is only a very minor user.
Yep.
And that the same mechanism to put pressure on the sites to be well used may not work.
Yeah, exactly. It's very well put. So one could say that the WLCG sites and the workloads went through 15 years of co-evolution, while the HPC are basically not in the same biotope as we are. It's a complete independent world.
Okay, so I suggest that we stop here for this very interesting discussion, and certainly this is a topic that we will discuss in the future. There were a couple of questions that were in the live notes and we don't have really the time to process, in particular one related to integrated climate related aspects to the benchmarking. So it will be for another discussion and topic. And there is also one, I don't know if you want to comment, there was Paolo who asked when the value, the compute value concept you presented, Marcus, as a chance to be usable to pledge non-x86 resources. Maybe a very short comment on it.
That depends basically how much workloads have been ported to these resources. So for
I'm talking about existing HPCs with existing workloads.
Okay.
Because that would be also a good dry run.
Yeah, it's actually a good point. So we should actually look into this and try to apply to these systems.
I feel a bit stupid because I cannot find a way to raise my hand, but let me make a comment on this. I think it would be valuable because of the discussion if someone, and probably this working group, could sketch how a process of pledging and procuring, including HPC hours, would look like with this new kind of benchmarking. I think, because I think myself in Prin is getting a bit confused about how this would work in practice. So I think now we basically have the tool, which is the work that Domenico and Marcus have shown. I think someone should give it a try and sketch how it would work in practice. And we can start with very simple cases, like you know, how it works for our grid sites today. And for example, how we would value an HPC site of some kind that gives us 10 million hours, you know, in a year, and they want this to be acknowledged in the pledge.
If for sure, US Atlas would be happy to participate.
And I think this would simplify a lot of the discussions because we would have something in hand, practical, that we can see and discuss.
Thank you, Simone, for this suggestion. I think it's a very good one.
Yep.
So